So good evening, students. So let us discuss today the concepts of bond energy, atomization, enthalpy of solution, dilution, hydration, and some numericals. Okay. Probably in couple of classes we can complete thermodynamics and thermochemistry together called chemical energetics. Yeah. A few things which I would like to discuss in entropy concept, that is entropy of fusion. So entropy of fusion. Fusion means so the solid will be converted into liquid. So this is represented as delta H fusion F. So you know very well delta S is equal to Q by T. Q means enthalpy. Q by delta H fusion by this temperature is fusion temperature. So this is the definition for entropy of fusion. Similarly, vaporization. When the liquid is converted into gaseous state, then we write here delta H vaporization. This is a boiling temperature. Boiling temperature delta H vaporization by T. Similarly, when a solid is converted into gas, then it is delta H sublimation. Then this will be sublimation temperature. Similarly, transformation. For example, sulfur rhombic is converted into sulfur monoclinic, or carbon diamond is converted into carbon graphite. This is a transition. Okay. Or a white phosphorus is converted into red phosphorus. This is a transition. So transition temperature. So these also how we can define entropy. So entropy of fusion, vaporization, sublimation, and transition. So let us move on with the numericals. So if the enthalpies of formation of ethene, carbon dioxide, and water at 25 degrees and 1 atmosphere pressure, these standard conditions, they are given. So whenever enthalpy of formation are given, so the first thing you have to do is write its reactions. So first you write these reactions. So when you write the reactions, determine the enthalpy of combustion of C2H2. So let us solve this question in a proper way. So first of all, enthalpy of formation of C2H2. So 2C, this is graphite solid plus 2H2 gas gives rise to C2H4 gas. This is enthalpy of formation of ethane. Next CO2, carbon graphite solid plus O2 gas gives rise to CO2 gas. Next, water. How to write water? H2 gas plus half O2 gas gives rise to H2O liquid. Hope you are clear. Now, what I require? What I require is this formula, this one. Now let us work out. Let us work out all of you. Now, C2H4, which side is there?
Left side.
Left side.
Left side.
This is which side? Right side.
Right
Right
side.
You have to do minus. Am I right?
Yes, sir.
This is minus. Okay. Now, next, forget about O2. CO2, which side is there?
Right side.
Right
Right
side.
side. Here, which side?
Right side.
Right side.
Right.
Plus
Positive.
addition.
Water, which side is? But one thing, how many CO2 is there here? 2
Two,
moles.
sir.
Two, sir.
This you have to into 2 you have to do.
Yes, sir.
This whole reaction. Next, water, how many? Which side is there?
Two
Right
moles.
side.
Right side.
Right
No.
side,
Side,
sir.
sir.
This also right side.
And
So this also
Sir,
Two.
addition.
Multiplied by 2.
this is also addition. So this is so you can see here. I mean, when you do this, naturally you'll be getting the answer. Are you clear or not?
Yes,
when you
sir.
manipulate this, you
Yes,
get the
sir.
answer. So you can see here 2 into 394 plus 2 into minus 286 minus 52. Clear or not? 52 is for ethane. This is 52. Agreed or not?
Yes,
Agreed or
sir.
not? Yeah. CO2, this is minus 394. This is minus 286. You can see the same manipulation is done here. I hope you understood how to work out this.
Yes, sir.
Actually, oxygen, it will be taken care. When you multiply with 2, it will be taken care. Are you clear or not? Oxygen stoichiometry will be taken care. Okay, you require 6 na here. The 6 will come naturally. Are you clear?
Yes, sir.
Now, let us see this question. Calculate the heat of formation of CS2. So this is the heat of formation of CS2. This one. So given data is given. So you have to manipulate. So how to manipulate? Very simple. First thing, carbon. Where is carbon which side?
Left side, sir.
Left
It is also
side,
left
sir.
side only. So this is plus
Addition.
addition. Next. Sulfur is which side?
Left
Sulfur
side,
also addition only, sir.
So these are also addition, but 2
Into
into
two,
you have
sir.
to do. 2
2
into
into it.
2 into
Two
you have to
moles.
do. Next.
Yes, sir.
Carbon disulfide is which side?
Right side.
Subtraction,
Subtraction,
Left
sir.
side, sir.
Minus, sir.
Clear or not?
Yes, sir.
You can
Yes,
see
sir.
here minus 395. You can see here minus 395 plus 2 into this one and minus of this one. You get the answer.
Sir, here in third equation, did they give the delta H value wrong, sir?
Third equation. I think so.
Yes, sir. Yes, sir. Okay. Sir.
Yeah. Actually, this is minus 1110. Na? Is it so?
Yes, sir.
Yes, sir.
Minus 1110.
Yes, sir.
Mistake is given. So this value is repeated actually. This is minus 1110 kilojoules. Clear or not? So the same value is used because you are doing minus this one. This is 2 into you are doing. This is positive only. This is also positive. The same thing is reflected here. Clear or not?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, fine. Now let us see enthalpy of atomization. Very simple actually. What is enthalpy of atomization? Enthalpy of atomization is always endothermic process. Endothermic process. For example, I take some metal. This is a metal lattice. Now, this metal is a solid. Now I convert into individual atoms. So this is an endothermic reaction. This is called enthalpy of atomization. Enthalpy of ionization is ionization enthalpy, ionization energy. So a metal is there. So a metal, gas, you knock out an electron. This is also gas. The gas is state only. This is IP. This is enthalpy of ionization. Are you following? Both are endothermic only. Enthalpy of ionization is also endothermic. Clear or not?
Yes, sir.
Both are endothermic in nature. So I hope you understood what is enthalpy of atomization. The amount of energy required to convert the metal lattice into individual atoms. So enthalpy of combustion, 1 mole of substance is completely burnt in its standard state. That is called enthalpy of combustion. So you can see you can completely converted into CO2 and water. And the heat always enthalpy of combustion is What reaction? Exothermic reaction. Enthalpy of combustion is always exo. Okay, that's why you get minus. Enthalpy of atomization, just now I explained, but anyhow you can see. So the enthalpy change on breaking 1 mole of bond to obtain atoms in the gaseous form. That is called enthalpy of atomization. So initially it may be in the solid, but you convert into gaseous form, individual atoms. Okay, that is what is enthalpy of. For example, here H2 molecule is there. You can convert into individual gaseous atoms. So these endothermic reaction, I told you already. Are you clear or not? Enthalpy of atomization example.
Yes,
Right.
sir.
The enthalpy of ionization already explained. Enthalpy change that accompanies the removal of an electron from a gaseous isolated neutral atom. You have studied in the first year. You have to supply the energy, it loses its electron. So here energy is required. This is endothermic plus. It can be expressed in electron volts, kilojoules per mole, kilocalories per mole, etc. If you supply more energy, second electron also you can remove. This is called second ionization enthalpy. This will be naturally more because you have to remove electron from the unipositive ion. Unipositive ion is very difficult to remove. That is the reason why always enthalpy is considered. How it is defined? IP3 is greater than always.
IP2 is greater than IP1.
IP2 is
IP1.
greater than IP1, sir.
Because very difficult to remove an electron from this unipositive.
Unipositive ion. Sir, unipositive ion is only considered for IP2 and
This is IP1, IP2, IP3.
so IP3
After removing, it will become IP1. When you remove this electron from this, it is called IP2. When you remove electron from this is IP3. When you remove electron from this is IP4.
Okay, sir.
So always second ionization enthalpy is greater than first ionization enthalpy for a given atom. So what is this notation? Enthalpy of
Standard
Sir,
enthalpy
of
combustion.
Enthalpy of
sir.
combustion,
Combustion.
sir. Standard enthalpy of
Listen
Standard
carefully.
enthalpy of combustion.
Enthalpy of
Standard.
for example, listen carefully. Enthalpy of combustion always sigma delta H reactants minus
Reactant
sigma
minus
delta H
products.
products. This you don't forget. Because in the heat of formation, for example, heat of formation of methane you take. So heat of formation of methane is carbon solid plus 2H2 gas. It will be CH4 gas. But combustion is considered, this reactant will be this side. If you write the combustion of O2, reaction is which side? CH4 is which side?
So towards the left side.
That's the reason why you have to write reactants here. Minus products, not products minus reactants. But heat of reaction is equal to heat of formation. We take heat of formation, this will be products minus heat of formation of reactants.
Yeah.
So these points are expected to address. These enthalpy of atomization. Just now you've learned
Yes, sir.
enthalpy of atomization. Bond energy. Very, very important. Bond energy is always same thing here also. Bond energy is equal to bond energy of the reactants minus bond energy of the products. Don't write the other way. I told you already, combustion and bond energy, bond enthalpy, reactants minus products. You should remember in thermochemistry. Clear or not?
Yes, sir.
Let's see the definition. Chemical reactions involves bond breaking and bond making. Energy required to break a bond, energy released when a bond is formed is always positive. So whenever you break a bond, it is endothermic process. Whenever bond is formed, it is exothermic process. So bond enthalpies of reactants. So total heat. Whether it is heat, see this heat of reaction may be positive or negative. Because if the reactants involves more energy to break the bonds and less energy is released, net will be endo. If less energy is required to break the bonds and more energy is released during bond formation, then heat of the reaction will be exothermic. Are you following?
Yes, sir.
But try to understand. Bond enthalpies must be reactants minus products, mind you please. These mean, I'll teach you what is mean now in the next slides. These bond dissociation enthalpy mean. What is the mean means? So bond dissociation enthalpy, change in enthalpy when 1 mole of the covalent bond of a gaseous core is broken to form products in the gaseous phase. Example you see here. Diatomic systems. So here you are breaking what type of bond? Cl and Cl.
Cl.
So these bond dissociation energy. Bond dissociation energy. Here, what you are breaking?
O2 and O2.
O2 and O2.
O and O. Bond O and O is broken. One pi bond and one sigma bond is broken. Mean bond means, listen, mean value. CH4, for example. In CH4, how many CH bonds are there?
The 4, sir.
4, sir.
Divided by 4. The total energy divided by 4 you take.
Yes, sir.
That is the bond energy of CH bond. That is the bond energy of CH bond. Clear or not?
Yes, sir.
Yes, sir.
1665. This is total. Are you clear or not?
Yes, sir.
Yes, sir.
Yes, sir.
Because H. So how many bonds, how many CH bonds you have to break?
4,
4,
sir.
sir.
4 CH, sir.
That's why you have broken this. And you have taken the average. Are you following? This is the total energy. This is the each bond energy. Can you see the average bond energy? In water molecule you take. How many OH bonds are there in water molecule?
2, sir.
So
Sir,
that's
2.
why
Sir, 4, sir. Sir, 2, sir.
2
2,
only,
sir.
na? Only 2. So that's why what you have written, heat of dissociation water by 2, why you have taken?
Because 2 bonds are
Because there
breaking.
are 2 bonds, sir.
2 hydrogen bonds are there.
No, 2 OH bonds. Okay.
Yes, sir. 2
Water
OH
is
bonds.
like this. 2 OH bonds are broken. That's why by 2 you are writing. Each bond is how much? Each bond. Here you see
457
457, sir.
457 kilojoules.
457. Similarly, this is the CH bond energy of each bond. How much? 416 is the average.
Yes, sir.
Yes,
CH4.
sir.
In
Yes, sir.
CH4. Are you clear or not?
Yes,
Yes,
sir.
sir.
Yeah. This understanding you should have in bond energy calculations. Now,
Sir,
same thing.
could you go back to the previous slides if you don't mind? One, I'll take the screen. Thank you, sir.
Now, let us see this reaction. Calculate the bond energy of CH from the following data. Okay. So, how do you get this? Huh? So, if you add, this gets cancelled. Huh? This gets cancelled or not? If you add, huh?
Yes, sir.
This gets
Yes, sir.
cancelled.
The
Gets
CO2 and
cancelled.
CO2 also.
CO2
CO2,
also will
CO2.
cancel. O2, 2O2.
O2 and O2
O2
also.
and O2
O2
is
and O2 will
cancelled.
be cancelled, sir.
So ultimately you get this. Are you
Yes,
clear
sir.
or not?
Yes, sir.
Or ultimately you get this.
Yes, sir.
So that is the manipulation you have to do. Anyhow, energy required to break a bond is always
Positive, sir.
Positive, sir.
endothermic. Endothermic.
Positive.
What is the formula for bond enthalpy?
So
Sir,
sigma bond
reactants
enthalpy,
minus,
reactants minus sigma bond enthalpy
products.
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 Reactants
First one.
minus products.
Products.
Right. Now I am going to take you to a lot of questions. We'll solve one by each. So concentrate here. Now, yeah. Calculate the bond energy of HCl. So given the bond energies of H2, Cl2 are given. Very easy. Okay. So here, listen carefully. Given the bond energy of H2 is given, they have given heat of formation for HCl is given. Heat of formation of HCl. What is the question? Heat of formation of HCl is given as minus 91 is given. Heat of formation. So let us see. So first thing, given the bond energies of H2. So H2 is given. This is the bond energy. When H2 is broken, Cl2 is broken. This is the bond energy. Okay. And H2 and Cl2 is given, right? Calculate the bond energy of HCl. So when you HCl, we don't know how much you have to calculate. Okay. Now listen very carefully. So here in this question, what you have to take? How to get this? HCl gives rise
First
to H
we
plus Cl
should
minus. This is required actually. How to get it? Why you have taken products minus reactants? But you have
Sir,
taken
bond
reactants minus.
formation, sir.
These are bond
get
formation.
the
Are you
heat.
following?
Okay.
So bond
Yes, sir.
formation, listen carefully. These are the bond formation, right? Formations you have taken. That is the reason why you have to take products minus reactants.
Products minus.
So calculate it. Half into 430. Similarly, half into 242, this one. So minus of minus 91. So when you do minus of minus 91, this, because HCl, which side you, HCl, so heat of formation of HCl means write this reaction, please. Heat of formation of HCl, please write this reaction. H2 gas plus, help me, Cl2.
Cl2.
Half, na?
Yeah.
Because
Yes,
heat of
sir. Half
formation is for
H2
1
gas
mole.
plus half Cl2 gas gives HCl gas.
HCl
This is
gas.
given. Delta H is equal to minus 91 is given. Clear or not?
Yes, sir.
Yes, sir.
So when you do minus, you'll get this. You have to manipulate these reactions 1, 2, 3 and all to get this. Say hello. This 1, 2 and this reaction, fourth reaction, you manipulate to get this reaction. Clear or not?
Yes, sir.
Yeah.
Yes, sir.
Now let us see this reaction. H2 plus O2 gives rise to H2O. So delta H is given. The bond energy of HH and O respectively are 104 kilocalories and 119 kilocalories. So let us understand this question. So here you have to use heat of the reaction is equal to bond energy of the reactants minus bond energy of the products. So reaction, what is given, how this reaction takes place? First, you have to break these bonds. Listen carefully. H2, 2H2. 2H2 means you have to break two HH bonds. And this bond also, O double bond, O bond also you have to break. And this bond should be formed. OH bond should be formed. Right now? Clear or not?
Yes.
And all the energies are given here. So write this, reactants minus products. So here, try to understand. Minus 115.4. Minus 115.4, delta H is given already. Heat of the reaction is given. Clear or not?
Yes, sir.
Delta H is equal to bond energy of reactants minus bond energy of products.
Right.
So this value is given already. So that's what it is, minus 115. Now listen carefully. Now bond energy of reactants. Okay. Bond energy of reactants. Now try to understand bond energy of reactants means, try to understand bond energy of 1 second. 1 second. So here you have to basically break. So hydrogen is like this. So 2 moles you have to break. So for that, what is the energy? 104. So 2 into 104 plus another reactant is there, O2. O2 how much is given? 119 is given. So
119.
119. Okay. Now products. So products, how many products? What is formed here?
H2O, sir. 2 H2O.
2 OH bonds are formed. Agreed? 2 OH
Yes,
bonds
sir.
are formed. So it is not 4 here. It is 2 OH bonds are formed. Clear or not? 2 OH
Yes,
bonds are
sir.
Yes,
formed. This you have to find OH bond energy. This OH bond energy you have to find. That is the only unknown. Am I clear?
Yes, sir.
Yes, sir. Sir, but
Yeah.
there are two H2O molecules,
yes, sir. They are
so
given
4
as
only, no,
2
sir.
1
H2
second.
plus.
2 H2O, right? Yeah. 2
Yes, sir.
H2 plus O2. Yeah. 2 H2O molecules.
Yes,
The
sir.
2 H2O molecules means
Yes,
4.
sir.
4 is required. Na? That's why
Yes,
divided
sir.
by 4 is coming. Okay.
Yes, sir.
You take 4 OH. 4 OH because 2 H2O molecule is given. Yeah, that's right. So these things you have to be very careful. Easy questions only you can solve. This enthalpy of solution I take in the next session. Okay. Because I want to just go with the flow. This I'll take up in the next session. Let me go for the numericals. Yeah. Let us solve this question. So resonance energy also I'll take in the next session. Okay. Yeah, let us see this question. Calculate the heat of formation of acetic acid from the following data. So heat of formation of acetic acid, you write. This is the heat of formation of acetic acid. See, 2 carbon graphite plus 2H2 plus O2 gives rise to acetic acid. This is required. Now, how to do the manipulation? You have to do the requisite manipulation to get these things.
Yes, sir.
Yeah. Now how to manipulate this? Let us see. Let me take this bar up. Yeah. Now, first thing is carbon. Which side is it? Carbon.
Carbon left side,
Left
sir.
side, sir.
Left side.
Left side. Here also left side only. So this you have to do plus. Agreed or not?
Plus.
But 2
Yes,
into
sir.
you have to do. Am I right?
Yes, sir.
Yes, sir.
Yes,
2
sir.
carbon.
Yes, sir.
2 carbon. Hydrogen. Which side is it?
Left side only, sir.
Left
Left
side,
side.
sir.
Left
But
side
2
only,
into
sir.
you have to
Plus
do.
Plus.
2 into plus.
2 into you have to do. O2. O2 is fine. Acetic acid. Which side is it?
Right side, sir.
Right
You have to
side.
do minus.
Here left side, sir, in the equation right.
Clear or not? So the
Yes,
same
sir.
thing is done here. You get the answer. Everybody is clear or not?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yeah.
Okay. So this you follow it. The other model is not required. There are 2 methods. You follow the simple method. Now, how much heat will be required to make 2 kg of calcium carbide according to the following equation? So CaO, because calcium carbide and hydrolysis will give acetylene. Acetylene is used as a artificial ripening. Carbide, that is called carbide. Artificial ripening is very dangerous for health. All fruits are basically ripened by this method. That's why we are getting a lot of health issues. Now, let us see. Heat of formation of CaO, CaC2, CO are given. So write these reactions first. CaO. How to get CaO? Tell me. Ca solid. Help me.
Ca solid plus O2
Ca
gas
solid,
gives
half
half
O2.
O2
half
gas
CO2
gives
half O2
CaO
na?
gas solid.
C.
CaO. Next. CaC2. CaC2 heat of formation.
Ca solid plus
Ca solid
C2
plus.
gas.
2C gas
Very good. 2C graphite solid.
graphite
Solid na?
gives CaC2.
CaC2. Good. Next, carbon monoxide. Carbon solid.
C plus
Yes,
half
Graphite.
O2 plus half O2 gives
Plus
C
half O2
gas.
plus half. Yes.
Agreed. Agreed or not? This is a gas.
Yes,
Agreed
sir.
or not? This is a solid.
Yes,
This is
sir.
solid. Now let us manipulate this. Agreed, na? You have to manipulate.
Yes, sir. Yes, sir.
Now when you manipulate, you get the answer. Now, how to manipulate? Tell me. What is required here? CaO. CaO is
sir.
which side?
So on
Sir,
CaO
the
right
minus.
side, sir.
right side,
Minus.
sir,
Minus. Calcium is here. Next, what is required? Coke. 3 coke. So coke is which side here?
Left
On
Sir,
the
side,
left
sir.
side, sir.
That is also
Addition,
left
sir.
side only. This is
So
positive.
3 into addition.
Sir, 2 by 3 times addition, sir.
2 by 3, yeah?
3 by 2 times or 2 by 3 times?
Yes, sir. 3 by 2 or
3
2 by
by 2, sir.
3 by 2. Okay. Next.
Okay.
And what about carbon graphite? Already graphite is this. If you add this, you get 3 na, you soup
Yes,
by 3
sir.
by 2. If
Yes,
you
sir.
add these 2, you get 3 na.
Yes, sir.
Yes, sir.
Yes, sir.
So I hope you understood this. Okay. So now try to understand. Now, when you solve, how much you are getting? 111 kilocalories.
111 kilocalories, sir.
But the question is, how much heat will be required to make 2 kg of calcium carbide?
Yes, sir. Weight by molecular weight into 2000, sir.
That's it. Weight by molecular weight into 2000. Because 64 grams, listen carefully. How much heat will be required? 2 kg of calcium carbide according to the following equation. So 64, what is 64? 40 plus 24. Agreed
Yes,
or
sir.
not?
Yes,
So
sir.
1 mole is giving this much heat, na?
Yes, sir.
So 1 mole is 64 grams. Now listen carefully. CaC2, this is 64 grams. This is equal to 1 mole. It is giving 111 kilocalories.
111.
But 2000 grams, how much? That is the
111
answer.
by 64 into 2000, sir.
Clear or not? Yeah.
Yes, sir.
This is how we should solve the question. Yeah, nice question. Very simple question. Now you are doing oxidation of this. You are getting CO2 water. Okay. Now bond energies are given. Happy na? Bond energies are given. First, how many reactants minus products? How many you have to break?
So
First,
4.
4 na?
Yes,
So
sir.
4 CH bonds. 4
CH
CH bonds.
CH bond.
C single bond. C 4 C single bonds. Agreed or not?
Yes, sir.
Yes,
Next.
sir.
1 C double bond C. 1 C double bond C. Agreed or not? What is the
Yes,
formula?
sir.
Bond energy of reactants minus bond energy of products
Bond
formula.
energy of product.
Agreed. So reactants only I'm writing. Next. Plus. What you have to break?
So
3
3
oxygen
O2 bonds. 3
O2
O2
bonds.
bonds.
This is given here already. Clear? Next.
Yes, sir.
Minus these are the products. So products formation, what is required? How many CO bonds are formed? 2.
4, sir.
So 2, sir.
Both, sir.
2 into 2, sir.
2 into 2, 4. So 4 into CO bonds. Agreed?
CO.
Hmm.
Okay, sir.
How many OH bonds are formed? 4.
4,
sir.
sir.
4. So naturally 4 OH bonds are formed. You get the answer. Net is energy is released. Because combustion reaction, what is expected? Combustion reaction is exothermic.
Exothermic.
Exothermic. You got it, na?
Yes, sir.
So any doubt? Let me know if you have any doubt regarding this. You're all clear?
Yes, sir.
Yes.
Bujji? Now, let us see another question. Let us see this question. Heat of combustion of CH4, C2H6, C2H6 are given. Which has the lowest fuel value in kilojoules per gram? So per gram, if you subject to combustion, you should get more heat, na? Clear or not? Yeah.
So I didn't get the point.
I didn't understand.
Okay. Nothing to worry. I'll teach you. See, which has the lowest fuel value? That means calorific value. Which is the best fuel? The fuel
More
is
heat in
should
less
have
amount.
high calorific value. Clear or not? That means when you take 1 gram of fuel, it should give more heat. Then this is the best fuel.
Yes, sir.
Yes, sir.
Here, what is the question? Which has the
Lowest fuel
Lowest.
value.
lowest fuel value?
Yeah.
So they have given combustion. Okay. Per gram is given. You require what? Combustion is per mole, na?
Yes, sir.
But
Yes, sir.
per gram, how you get by molecular weight?
Yes, sir.
Yes, sir.
Yes, sir.
By molecular weight, you do it all. Now, how much is getting? 55, 50, 52. Which is lowest?
T2H4.
50.3, sir.
The lowest. So this is not a good
50.3.
fuel. Relatively, this is not a good fuel. Clear or not?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. So examination, always kilojoules per mole will be given. But fuel value, how do you have to see? Sometimes calories will be given. Calories per gram you have to take. Clear?
Yes, sir.
Yes, sir.
Yes.
It's a very simple question. This question is formation of LiCl. Li and Cl. How to form LiCl? First of all, this is a solid. This should be converted into gas. This is called sublimation energy. This gas should be converted into Li plus
Yes.
Yes.
Ionization.
ionization potential. This Cl2, na? Cl2 first of all.
Yes, sir.
Cl2 should be dissociated first. First it should be dissociated, D/2, because 1 Cl is required. Now this Cl you have to add electron affinity. It becomes Cl minus gas. These two will combine. This is called lattice energy. This is lattice energy. So that's why you write, just add these things.
Yes, sir.
Because, yeah, this is endo. Sublimation is endo. Dissociation energy is endo. IP is endo.
Endo.
And electron affinity is exo.
Exo, sir.
Okay. Are you following or not? So accordingly, you get the values. This is exo. Minus, then you get the lattice energy value. Which is exo. We'll get the value in exo. Generally, you add everything, but you get the value in exo. Clear or not? Heat of formation is given. Heat of formation. This is heat of formation. This value is given.
Yes,
Clear or
sir.
not? Yeah, this is Born-Haber cycle. Already explained Born-Haber cycle for you. Born-Haber cycle is equal to delta HF is equal to sublimation energy plus IP plus EA plus dissociation energy
Dissociation energy
plus
plus
lattice energy. Lattice energy. So this is exo, this is exo, remaining are endo. Yeah. Let us understand this question. Bond dissociation enthalpies of H2 and N2 are. So H2 and N2 are given. Enthalpy of formation of ammonia is minus 46. What is the enthalpy of atomization of NH3? What is the average bond energy of NH? Nice question. Now first, so let us see. So how ammonia is formed? First, you have to break these bonds. What bonds should be broken for ammonia?
N bond. Nitrogen.
N triple bond N. So what is the value given?
436 kilojoule per mole.
436 and also 941 both. H2 na? How many H2?
Okay, yes, sir.
3 H2.
3
H,
moles, sir.
3 H2 reactants. Minus, listen carefully. So here, first thing is N triple bond N plus HH bonds 3. It forms 2 moles of ammonia. Agreed or not? So
Yes, sir.
this is how much? How many bonds? NH bonds? 3 NH bonds.
3, sir.
3,
So this is 2. 2 into 3, how much? 6.
6.
6,
This is,
sir.
let us take this as X. Clear or not?
Yes,
X is
sir.
equal to bond energy of NH.
Yes,
Clear or
sir.
not? Yeah. So now listen very carefully, very interesting. Now listen. Here the question is, what is the enthalpy of atomization of NH3? Atomization of NH3 means nitrogen and 3 hydrogens. Agreed or not?
Yes, sir.
yes, sir.
So how much value X is coming? 380.
380.3
380.3.
380.3. Right.
So, but there he kept 390, sir.
It's 380 only. It's a soup.
Yes, sir.
Maybe I think some mistake is there here. Or it may be 390. Okay. Because 9 3 is 27 is there. Huh? So maybe this may be 390. Okay. I hope you understood this.
Yes, sir.
It's not automation, atomization. Clear or not?
Yes, sir.
So thermochemistry questions you have to practice. It appears when I'm teaching it is easy, but it's not that easy when you are practicing. Now let us see one more question. Heat of neutralization question. The temperature of 5 ml of strong acid. So strong acid 5 ml is mixed with 10 ml of a base. 5 ml of acid is mixed with 5 ml of a base. So what is the increase in temperature? 5 degrees.
5.
See, you have a calorimeter. Try to understand the question properly. You have a calorimeter. So here you are adding acid and a base. Here you have water. Here temperature, when you add, what happens? Heat will be released, na?
Heat will release, then water
Yes.
will absorb the heat.
Then there is a temperature difference. 5 degrees increase is there. Are you clear or not?
Yes, sir.
So if 10 ml of each is mixed, what is the temperature increase? That is what is the question. Now temperature is, you know very well, Q is equal to MST. Agreed or not?
Yes,
So
sir.
delta T is equal to delta H by MS. Agreed? Yeah. When 10 ml of the reaction is increased, then mass will become 2m and 2 delta H because extensive property. Delta H is extensive property, depends on mass.
Yes, sir.
Now 2 delta H by 2 ms. So temperature increase will be same. Clear or not?
Yes, sir.
Yes, sir.
Yeah. Now see the question. In case of mixing of a strong acid and a base, one normal concentration, temperature increase is the highest for. Come on. 20 ml, 30 ml. So how much heat will be liberated? For 20 ml only? Neutralization. This is excess, na? Limiting. This
Yes,
is
sir.
limiting.
Limiting.
Yes,
10
sir.
ml acid,
Here
40
10
ml
is limiting.
alkali. How much will come?
10 ml
10
only.
ml, sir.
10 ml, sir.
Sir,
25
option
ml
C,
acid,
sir.
25 ml
25.
acid, 25 ml alkali. How much you'll get?
25, sir.
25.
25 ml, sir.
25 ml. Next 35
15
ml and
ml,
15
sir.
ml. How much is
15
coming?
15 ml.
15 ml,
15
sir.
ml. In which case heat will be more?
Option C, sir.
C is more.
C, sir.
Clear or not?
Yes, sir.
Yes, sir.
Simple question. Okay. So this is how you can solve the questions. So, and you can now there are resonance energy questions, enthalpy of solution, enthalpy of hydration, dilution. These questions are left out. Okay, remaining and all I've practiced it. I think in 2 more classes we'll complete the course. And tomorrow is off for you on account of Republic Day. So any questions, please?
So before question, you told that Q is equals to MST, no, so that I didn't hear, sir. I didn't even read it in the books.
Temperature, this same thing only, bomb calorimeter. Okay, I already explained na? Here. When you mix here,
Yes, sir, that one I understood, sir.
yeah, Q is equal to MST. Here Q is equal to delta H. This is MS delta T. What is your problem?
Okay, sir. Sir, I didn't. I don't know that form, sir. I didn't even read it.
Okay, you can read.
Okay, sir.
Any other questions, please? Okay, thanks for bearing. Have a good day.
Thank
Good
you.
evening
and
and
thank
thank
you,
you,
sir.
sir.